Welcome everyone to the first KUIS AI talk of the fall 2023 semester. I'm really excited to introduce our next speaker, Assistant Professor Eunsol Choi from the University of Texas at Austin, who will be talking to us today about knowledge editing in LLMs. And Dr. Choi is a leading researcher in NLP with a particular focus on knowledge editing, long-form question answering, human-LLM interaction, and spoken language processing. Her work in question answering has been extremely influential, like including her contributions in Trivia QA and Quack. She has won many prestigious awards such as Google Research Award and EMNLP Outstanding Paper Award. She is also a recipient of grants from Google, Sony AI, Cisco, and many other institutions. And I'm really thrilled to welcome Dr. Choi and to learn more about her cutting-edge research. And also just a quick reminder, like the professor said that she prefers taking questions during the talk, so feel free to ask your questions during the talk. Thank you.
Okay, thanks for kind introduction and inviting me. I'm excited to talk about my research. The title is Knowledge Augmentation for Language Models, and I'm going to talk about two aspects of knowledge augmentation: retrieval-based augmentation and then knowledge editing. Okay. So I think all people know that like language models are pretty impressive. We are training really large models that's memorizing trillions of tokens. So while it's like trying to predict the next words, it like remembers a lot of facts about the words. And it gathers this kind of information from Wikipedia, social media articles, books, and so forth. And when we inspect what's going on in this language models, we can see it actually memorized a lot of things that was in the pre-training corpus. So there has been this study last year that I cleared. They found they give this prefix from the training corpus and see whether the language model will be able to continue what was in the training corpus, the continuation of the prefix. And they saw that the larger models were a lot better at remembering and copying verbatim what was in the training corpus. So these were the graph that they were showing. The larger and larger models, they can reproduce the text in the pre-training corpus a lot better. And if the same prefix or prompt was repeated multiple times in the pre-training corpus, then it also got easier to extract. So language model during this pre-training remembers the stuff. And now we are basically using language model as some form of implicit knowledge basis. So I asked this question earlier about like, please tell me about the history of Turkey in one paragraph. And ChatGPT was able to generate this fluent paragraph discussing the history of Turkey. I have no idea whether this is like factually accurate or not. Maybe you are better judge of this particular question. But basically, we can kind of know that language model now knows a lot of this like word knowledge. And there are works that's like trying to recover knowledge graphs from the language models as well. So after we have built this language models, we are using this language model for various tasks, such as question answering. Like you ask a question, like please tell me about the history of Turkey in one paragraph, and then the model generates an answer. And there are some issues of using language models in this fashion. One issue is that when you ask about popular and prominent entities, the answers are typically correct and a lot better. But if you go to long tail of entities and ask about less prominent entities, the quality of the answers goes down significantly. So there has been the studies, depending on how many times the entity was mentioned in the pre-training corpus, the more frequently mentioned, the model's accuracy was a lot better. So it cannot handle this long tail information very well. And also, more importantly, there was this issue of like hard to verify the correctness of the information because there is no citation or notice where this information is coming from. Right, so this is on the hotspots of like all the data in the web. So there were these issues, and there were other issues of using LLM's knowledge. I asked this question to GPT-3 earlier this year, who won the most recent Grammy Award for Best New Artist, and it gave me an answer, Billie Eilish. Any pop culture fan, is this correct or incorrect? Which is famous, so it was true as of 2018, but I asked this in 2023, so it was not the correct answer. Similarly, if I ask about Prime Minister of UK, the answer I got was Theresa May, and true for 2015 to 2019. And when I was talking about this, some people are like, oh, LLMs got better, they don't do this anymore. And it is true. I asked the question like more recently, who won the most recent Grammy Award for Best New Artist? It's the exact same query. And they showed a different behavior. Instead of giving me the incorrect answer, it was now abstaining from answering, saying that it has a knowledge cut of 2021 and cannot answer it correctly. But then when I ask a slightly a more tricky question that doesn't yell that it's going to change over time as much as this question, which has this keyword most recent. For example, list researchers at the University of Texas at Austin in computer science. Then it gave me a list of like 10 prominent faculty in our departments. Didn't include me yet. I think I'm a young faculty. But out of those 10 faculty, 3 people were no longer at UT for various reasons. They retired or they moved to industry or other universities, but it was giving me the outdated information. So this is still an issue. We train this language model, which picks up the knowledge, and then the knowledge moves on, but the knowledge in the language model is kind of stuck in the past. And there has been studies looking into this. The study from DeepMind was looking at language model performances. So it's just measuring the perplexity, but you train the model with corpus up to 2018, and then like evaluate on newer corpuses. And you can kind of see that the perplexity was increasing as you go farther and farther away from the time that it was pre-trained on. And we know that language modeling performance like kind of transfer to other end task performances. And more importantly, there was this recent study paper came out, says that this effect of pre-training temporal misalignments are stronger for larger models than smaller models. So it's not something that you can get by just like scaling model to be larger and larger or feeding more data. I think this is like a larger gap in the larger models because like larger models got better. So the gap was higher because it was better, and then that it loses that functionalities. So these are issues, and this temporal drift, one of my students was really excited about this topic, so I've thought about a lot. And there are 2 types of temporal drift. First is the question distribution shift. So for example, new event in the world happens, like Malaysian airline 737 disappearing, or COVID happens, like these kind of big events happens. And now you get the questions you have never gotten before, right? Because there's new events. So this is kind of distribution shift in the questions. But more importantly, I think the more tricky thing is actually the question remains the same, but then the answer distribution is changing. So this was what we studied in the MNLP 2021 paper, situated QA, where we're posing the same question, but then seeing whether the answer changes based on when the question was asked or where the question was posed. So where were the last Winter Olympic Games held? At some point it was Sochi, but then it moves on to Pyeongchang and then Beijing, and it's going to change again, right? And when we looked at popular open domain question answering data sets, all data sets have these kind of questions. 13 to 30% of questions on these data sets were having this temporal volatility where the answers are changing. There were questions where answers never changed, like who founded Google, who was the first president of the United States. These questions never changed the answer. But there are a lot of questions where answers are shifting. And one thing that I also would like to say is that if you think about the user's perspective, I think more questions that's getting asked are actually temporally dependent, because if it's not temporally dependent, you ask a question, you get an answer. Hopefully you remember the answer and you never ask that question again. But when the answer is changing, you ask the same question continuously. Like I ask every morning, how's the weather? So there are just two types of temporal drift. And how do we address this? How can we augment the knowledge that the language model have so that it can catch on this up-to-date knowledge? Okay, question, yeah.
Is there any evidence for, let's say, when you ask who is the first president of the United States, it says George Washington, but like when you ask recent questions, it has to learn. But is the learning new facts difficult than changing the fact in language models?
It's a great.
Is there any evidence for it?
It's a great question. I think. Yeah, I think this question actually is not that easy to study. I'm going to talk about like adding new facts and changing existing facts later in the talk. But I think the definition of existing fact is also a bit difficult because you don't know what's in the pre-training data. And also, I think there is conflating two factors because like new facts are usually about less prominent entities and models know better about the popular entities. But yeah, I think those are interesting questions to study.
Okay, thank you.
Yeah. So what do we do when we are trying to look up the up-to-date answer, right? We don't only rely on our memory because our memory gets outdated. What we do is we use web search and try to look up for like most recent documents. So that's like kind of what's been going on with language models as well. We are trying to augment language models with retrieval. So models gonna use, I'm gonna recall this like facts memorized during pre-training is parametric knowledge. The parameter in the language model remembers these kind of facts. And then you were gonna use non-parametric knowledge, meaning that the documents the model we're gonna retrieve at inference time. So basically you give the model function to Google. So these are this work, and then you retrieve the documents that's relevant to the question that you have. And then the model will now use both the parametric and non-parametric knowledge to generate the answer. It sounds like a pretty neat solution, but I'm gonna talk a little bit about like why this is still not a sufficient solution yet. So one thing is that when we are using this generative search engine, there are, I think, like 4 or 5 companies that's offering this kind of generative search engine. You type something, you pose a question, and they generate text based on the documents that they found on the web. And there has been this study from Stanford earlier this year that if you actually look at whether this sentence that says it's cited from passage 1 is actually supported by passage 1, the quality of this citation was somewhat limited. So even when it says like it's coming from this passage, sometimes it's not. So there's still room for improvements. So in the first part of the talk, I'm gonna talk about this like augmenting LLMs with modules that can provide up-to-date knowledge at inference time. So basically doing this retrieval augmentations, but I'm gonna introduce couple more different modules to improve this retrieval-based approaches. And then in the second part of the talk, I'm gonna talk about instead of providing this new document at inference time, inject the knowledge into the parametric knowledge, the language model's parameter itself. So first I'm going to talk about this like retrieval-based augmentation. It's pretty simple fix. So you have a query, you do the retrieval, find the document, you prepend this document to the language model before you ask the query, and the language model uses this document as well as the query to generate the answer. You don't have to update the model parameters, and you can use whatever language model you want, even the black box APIs. But there are some issues with these approaches. The biggest thing I think is the inference cost increases because we are prepending a large amount. Like if you retrieve a lot of information, then you have to prepend all those information. So inference cost increases. And also, there are more and more evidences. If you actually retrieve irrelevant or incorrect information and then prepend it, then the model's performance gets actually worse than not prepending. Question?
Also, does these large language models always stay faithful to the retrieved text? Like, do they just sometimes ignore the text and, output whatever is in their memory or something?
Yeah. So I'm going to talk a little bit more about that. That's a great point as well. Yeah, model is not always paying attention to what's prepended. Partially because it's never like trained that way per se. So I think training large models with retrieval in mind is important, but most of the open source model that we have at the moment doesn't have that.
Thank you.
So we're going to try to improve this retrieval-based augmentation by introducing different modules that can leverage external resources. External resources can be expert annotated data or different models or different knowledge that you can look up. And we kind of build this kind of pipeline system where we apply first module, get the output, apply second modules, and so forth. And there has been, this is also another popular idea that's been explored a lot in the field at the moment. This tool former was introducing these different tools like calculator, compilers, and so forth. And here we are doing this kind of module augmentation for knowledge augmentation through retrieval. That's our focus. And the test that we are interested in here is a real-world political fact-checking. And I think one of the idea is that like the language model generated texts are now getting more and more fluent and more human-like. So maybe we should access like how factual or how good is this text, just as how we were evaluating human written text. So say Joe Biden was made a statement a couple of years ago when I was vice president, violent crime fell 15% in this country. The murder rate now is up 26% across the nation this year under Donald Trump. If you wanted to verify this statement, what would you do? So what human fact checkers do, it seems to be, is first decompose this claim into multiple series of facts that you have to check and verify. There are some pretty easy things like numbers, whether 15% was correct or 26% was correct. But then also the expert fact checkers also look into like what are some important things that should be relevant to this statement that Biden is leaving out. So after you decompose this claim into multiple things you'd like to check, you go search the web and gather the data. And then after you gather this information, you write this beautiful summarizing paragraph that explains the judgment that it's giving, that it's half true because the numbers are correct. But then experts think that comparing this crime rate with murder rate is not fair. And also it's not on the same time interval. So this is kind of like our grand vision of going there. And toward there, we are doing this multi-stage knowledge augmentation. We start with the claim. We decompose this claim into kind of atomic sub-questions. And then we retrieve the documents, and then we summarize those documents. And then based on the summarized documents, we train the model to give this verification label, whether it's false or true. We are not at the stage of generating this beautiful explainable paragraph, but our goal was to it's a kind of first step towards that direction. And here we are just gonna evaluate on whether we can guess the labels correctly.
Let's say we are searching for something up, and the retrieval, retrieve the irrelevant document, and we then sort of give a feedback to the model that this is not what we are looking for. Are the model capable to changing its prompt so that we could find more relevant articles so that we would give most correct answer to the users, but for the claim decomposer, or way to change the prompt in claim decomposer rather than using a single template in this setup?
Yeah, that's a great question, whether we can kind of do it iteratively. Human can give feedback, or it's not working well. Can it go back and then like do more retrievals and so forth? We haven't experimented in this work because it's kind of like starting point. But I have one slide where we're doing something like that, basically improving the summarizer based on whether the summary is helpful for the downstream LM or not. Yeah, I think that's also a great direction for future research. So I'm going to explain these modules one by one briefly. The first module is claim decomposition, where you start with the claim and then come up with this statements that you would like to verify. And there are just literal questions that can be directly derived from the claim, like the number, whether it fell by 15% or it rise by 26%. So these are you can kind of get from manipulating the original claim. So we call this like literal questions. And then there are implied questions that are a little bit trickier. That's not explicitly stated in the claim, but also you have to check, because that's like what the claim is implying. Like whether it's from the same interval or are they comparable, for example, in this case. This was our UMLP paper last year. And how do we do this decomposition? We collected about 1,000 annotated data with high quality query workers and then trained the models. But then later we found if we carefully prompt like GPT 3.5, then the models can do this task pretty reasonably, as well as the fine-tuned model. And then there's like not a good way to evaluate this. So we did a human evaluation where annotator compares this sub-question with the generated gold sub-question and then generated question set from the model. And this gold question set were generated by annotators where they're looking at this explainable judgment from the professional fact checker and then kind of reverse engineer what kind of question this fact checker was answering. And literal questions were relatively easy for models to find. But then the implied questions, the models were not able to generate very well. So there is still room for improvements in this axis as well. But we got somewhat reasonable results.
Let's say you have a perfect like retrieval system and LLMs are capable of answering every question correctly, but the sources are very important. For example, for this Biden question, you might get sources from 4chan or Reddit or from official government institutions. How can we differentiate this official citation so that we can ensure that our models can answer it correctly? Because otherwise, even if you have a perfect system, it's irrelevant if you don't know what are the official records.
Yeah, that's a great question. That's something that I've been thinking actively these days. Like, what are we gonna do with the quality of the information sources? But for now, I'm not considering that, thinking that that's like beyond like research of NLP. It's more sociological problem. Here, I'm gonna assume whatever sources that I'm finding is reasonably accurate. Yeah. Other question?
So let's say they are 100% true, but like for example, Wyden said that the crime rate fell to the 15%, and while Donald Trump on the US there was up to 26%. So what will be happen if Biden said it will just increase 2 times higher than me, but all of the papers it's just tell these scores of like 15%, like percentages, like 26%. So the information will be there, but I believe the model cannot understand the difference between like multiplication or something.
Well, I think that's like kind of goes to entailment, whether this set of claims can entail this other claim. And we assume that the models are capable of doing that entailment at this phase. But yeah, it's not a solved problem, but yeah.
Okay.
Okay, so that's the question decomposition part. And then in terms of retrieval, we just do the Bing search. I was a little bit uncomfortable doing this. This was almost first time that I used commercial search in my research. And like the big issue is like it's not reproducible. We actually did a little study in the appendix. Like we'd post the same query a couple hours later. Do we get the same results? We don't get the same results. But at the same time, if you want to solve this real world problems and gather this real world information, I don't think there is a way around it. I don't. So anyway, acknowledge that this is like not a reproducible research, but we did this. And then we have this get the like 60 pages from Bing search, and then that's still a lot of information we can feed into the language model yet. So we did kind of second stage retrieval that's gonna pick out the relevant pieces from this like a still large amount of text. And we found that instead of just using raw claim, actually using this decomposed questions actually ended up retrieving better documents for us. Yeah, you can look into paper for details. Yeah, so but we are using this decomposed question for queries for retrieval, and then we do the summarization of the retrieved documents according whether with respect to the claim. There has been studies showing that this large-scale LLMs can now reliably summarize single document in news domain. So, you know, this is Da Vinci model. And then if you compare the score of faithfulness or coherence or relevance, you can see that it's like better or equivalent to reference writers in most cases. So for a single document summary in a news domain, the models are pretty good. So we are using this larger model to do this claim-focused summarizations, given the documents and the claim. So this was the prompt that we used. Yeah, you should give a clear and concise summary and make it into 1 to 2 sentences that's relevant to the claim. We did some human evaluation later, whether this actually generates faithful or coherent or relevant summary. Mm-hmm.
This is, as far as I understand, the unconditional summarization. But have you like tried to given this is the fact that I'm looking for in this document, more like conditioning summarization?
Condition on what?
Conditioning on summarization, because like you have some questions or facts to check. You are saying this is my facts, and search these facts in this document, rather than just summarizing the document. Give a summarization related to this, I mean, instruction or input.
Yeah. So we are doing a claim-focused summarization. Like we are asking to summarize, like with respect to the claim that we are giving.
Then you are including in prompt as well, right? Your claims.
Yeah.
Okay.
So here are some examples of generated summary. This was the claim. It was about some voting fraud, and then it was able to generate summaries of the long documents that's kind of relevant to the claim. We did a human evaluation on this summarization part. First was faithfulness, where the information in the summary are faithful to the information in the original documents. And we found that it's not perfect, but it's somewhat reasonable. The other is whether the summaries contain all the information to answer the subclaims that we have generated. And here we got a little bit more mixed results. Some of the sub-questions can be answered based on the summaries that's generated. Some were unanswerable given the information that we were able to find from the web. Mm-hmm.
Like, what's the context length of the document? Like, have you tried very long context documents, which like models will probably struggle to do summarization?
So we did. Go ahead.
Well, we can ask you.
Yeah, we did the second stage retrieval, so we don't fill all the documents. We do like kind of BM25 to figure out the relevant parts from the documents and only give that part. I think it was like less than 1,000 tokens. I can't remember exactly. Yeah. It's not the most elegant solution, but yeah, it works. And then after we get the summaries, we concatenate them, and then pass to the classifier, and then get with the final veracity judgment. And it's trained on small scale, like it's 1,000 examples of claim paired with the veracities that you're using from the fact-checking website. So this was a kind of modular augmentation fact-checking that I was showing. Some parts were learned from the annotation. Some are using this commercial search engine that can bring in this external knowledge. And then we have the summarizer, which is going to use like a larger model that uses human instructions. And then veracity classifier will be supervised with the small scale data that we have. And you can see that these are the results on our test set. Compared to using the claim only, our system of this pipeline was able to show meaningful gains, but still it's like far away from when you train the classifier using the bold justification written by the humans. And actually, I think a lot of gap there is like some information is just not in the web. Yeah, so the grand goal was just making this explainable judgments. We are a little bit far from that at the moment. Like what we have is the summarized individual documents, and then the label, right? So that's our goal. So towards that goal, I think there are many missing pieces that we would like to address. One thing that's been keeping me up at night, or like we kept thinking these days, is doing multi-document synthesis. I think models are pretty good if you give one coherent document, but if you give like, different snippets from different documents that doesn't share the context, like how can we merge the information from them together? We actually tried the multi-document summarization, and then we ditched the approach here because the models were not being faithful. Like it started making stuff up. And limited recall on relevant knowledge, this I don't know how to fix it. Yeah. Question?
So my question is that, like, is these fact-checking questions are more about details, but when we say just summarize the document, it gets more of a general knowledge. So is that some kind of a problem? So for example, we say like the crime is decreased like 15% or something, but when we say summarize the document, it can say like the crime is decreased or something, just because it is, trained to give a more general perspective.
So we give the claim and the summarize with respect to the claim, so it doesn't do that.
Okay.
Yeah.
Okay.
Yeah.
Thank you.
Mohammed? Yeah.
I was wondering, how does the model determine what's the relevant information in the document?
Right. I mean, that's the black box GPT magic, I guess. Yeah. I think like during the instruction and tuning and stuff, it learns like what it means to be relevant, and semantically matching. Yeah.
I see, thank you.
Yeah, another very great answer. Yeah. And I think another thing that's missing is like we're currently learning this individual models independently, while like they all work in conjunction. So we should ideally learn them more jointly. So there are these things that we would like to work towards. In the last thing about learning things jointly, we just put this paper on arXiv yesterday, where we are doing this summarization. But then we are learning the summarization model instead of using the off-the-shelf GPT model. And how we are training this compressor models, we are going to look into whether the compressed summary and then feed into the language model, and then whether the summary will going to help the model to generate the correct answer or not. So we are going to use that signal to train the compressor. And we want the compressor to have this functionality, so it should be concise, useful for the downstream language model, and then faithful towards the documents. You can look at the paper for details, but we are able to achieve like 5 to 10% compression rate. So original was like 749 tokens, but we only gonna prepend like 58 tokens, and then get very minimal drops in performances for language modeling and open domain QA task. So the goal here is like, it's going to be more efficient because like when you're using this black box language model that's expensive, we are going to only pass in fewer number of tokens. But also you can filter out stuff from the retrieve document that's irrelevant. So a little plug about our recent work. And with that, I think I would like to move to the second part of the talk, where instead of providing this non-parametric passage at inference time, how can you actually update the model parameters? And you might ask, like, why do we have to do this? Can you just do the, retrieval augmentation? Like, can you just leave the language model as is? And I think even though retrieval augmentation works pretty well, we have to do this updating language model because even when the model is provided in documents, model keeps using the parametric knowledge in a very subtle ways. So I'm gonna show some our studies on looking into this. So in this EMNLP paper, we ask a question, it's simple questions, and then where the answer is like an entity from natural questions. And then we only look at questions whether model got it correct without looking up the parametric knowledges. And then we found this passages, and then we swapped the answers from the passages to some distractor entity. So instead of Norway, we say Italy. And then we give this passage to the model and then see whether we're gonna say Italy or Norway. So if the model is like looking more into the non-parametric knowledge, it's gonna say Italy. If the model is using what it has remembered, then it's gonna say Norway. And this model was FID, fusion and decoder model, which is encoder-decoder model that takes up to 100 passages. So we are substituting these answers on like 100% of all the passages, or half of the passages, or 25% of the passages. That's what we're gonna do. So you swap 100% to the new entity, or half, or 25%. And then we were gonna look whether the model we're gonna say the new answer or old answer. And surprisingly, after the swapping all, there were some percent of questions where the model is still outputting the old answer. And actually, model got confused and like didn't give either of the answer for like 30% of questions. If you do the 50% swap, if it's not using parametric knowledge, it should be half and half. But that was not the case. The original answer was outputted about twice as frequently. So model is still using this parametric knowledge. And this was kind of older model from 2021. And we did a newer study we are going to put on archive in the next couple of days, where we are looking into up-to-date model like WebGPT or GPT-3 or Alpaca, and then doing this long-form question answering where you are solving harder problem of generating a paragraph length answers. And then we are looking at whether if you prepend this relevant documents, how much of the answer that you are generating can be grounded to the document that it's provided. So we are looking at each individual sentences and see whether it's supported by documents or not supported, probably coming from some parametric knowledge. And we found that the language model, the WebGPT, is the only one that we looked at that was trained with retrieval, but the others were, GPT-3, I don't know what's going on, but they are not necessarily retrieval augmented pre-training setting. And we see on those models, many of the sentences generating are not supported by the evidence document, even when we give very relevant evidence documents. So point that I wanted to get across here is the model we're going to keep using parametric knowledge in a way that's very subtle. So we should update the parametric knowledge as well. Well, that's what I'm going to talk about. And this is an interesting research question. Yeah.
Have you used any like base model that is not fine-tuned supervised, like with Alpaca dataset or something? Because I believe like supervised tuning might, first base models capabilities in some sense.
Yeah, so the thing was like for this task, it's such a difficult task. And we tried like, I think my student tried like 7 different open source model, and non-instruction tuned model just wasn't able to generate a fluent answer. It was just like repeating same tokens over and over again, or it just crashes. Like this is really hard task. Without instruction tune, we couldn't even get the reasonable answer.
My second question is, I guess when you ask like medical questions in like GPT-4 model, it will like ignore it or say that I'm not a medical expert to answer it. Like, have you tried on models which are like RLHF so that they won't give any answer for it? And like, is it a good thing or like giving the document, but they are not able to answer it? Does it mean that they have the worse performance or better performance at the end?
Yeah, I don't know. I don't want to go into, I don't think I haven't really explored that much. Yeah. Okay, I think we're running a little bit out of time, so I'm going to move on. So people have worked on this problem, inject the facts to the language model. So, Prime Minister has changed. It's not Boris Johnson or Liz Truss anymore. We want the model to reply to Rishi Sunak. So we update the model parameter with this new thing, and then evaluate the targeted accuracy. So it's going to update the new answer, and then it's not going to impact other sentences that's not relevant to what's injected. There has been a couple of methods that's proposed, and overall they work pretty well. Pretty well in a sense that they can repeat what's exactly injected. But what we wanted to look at is like, can the model not only repeat what's exactly injected, but can make inferences based on the injected facts. So if we learned that Rishi Sunak became the Prime Minister of the UK, then would it know that Rishi Sunak now lives in 10 Downing Street, which is the residence of Prime Minister, the fact that I learned from The Crown. And then also Rishi Sunak will attend various international events as a representative of the UK. So we named this kind of like knowledge propagation and wanted to see whether this is really happening. To study this, we started with our prior work on new entities. So these are like trying to make the evaluation focus on the instead of updating knowledge, whether we can inject new knowledge. So these are entities that are like have the origination date according to Wikidata, like mRNA vaccine is a thing that only happened in 2021. Some other things in the our ontology includes like earthquakes, TV shows, stuff like that just have like very clear start date. So we found these entities and then look up the Wikipedia of these entities and then find the first sentence of the Wikipedia as its definition. And then we take all the other sentences in the Wikipedia about that entity and use it as a probe sentence. So, and then you find some parts of the sentence, you mask it out, and then evaluate whether model can predict the target that's masked out. The whole idea is if the model have remembered or learned about this entity definition, it should be able to make a better guess on filling in the blank on these probe sentences. And you can generate this completely automatically. So this is the task setting. We are studying this knowledge propagation. So we inject this entity definition, we update the model parameters, and then evaluate whether now the model we're gonna be more likely to give more probability to the target Y that we are trying to predict. This is slightly different. We are not evaluating exactly what's injected, but relevant sentences that should be easier to guess once you have acquired this new knowledge. So how are we going to do this thing? The first thing we're going to do is this retrieval augmentation, where we just prepend the definition in front of the probe sentence and then see whether the model's ability to guess the mask out tokens improves. We test the same pros and cons that I discussed before. And here's the results. So this is the perplexity of the predicting the mask out token, and this is like input as is. And if we prepend the correct definition, the perplexity drops significantly. So it helps. And then if you actually put a random definition in front of it, then it gets a lot worse. So adding definitions helps, adding irrelevant definition hurts. So this kind of goes back to what I was talking about. Retrieval augmentation is great if it's relevant, but if your retriever fail, then it actually hurts the model. But here I wanted to do the knowledge instead of prepending. It's just like, it's not really scalable because you cannot keep prepending and prepending and prepending. So you have to update into the model parameters. So the baseline that we're gonna use is just do the continued pre-training of this entity definition. Let the model to predict the next token, update the model, and then do the evaluation. Let's continue the pre-training on the sentences that's new. Right. It's the simplest possible way to inject knowledge into the parameter space. So yeah, and then when we evaluate on the loss on this entity definition, it's doing great. Like it can predict what it's been injected. But this now has some other issues. One is that now we are updating the model parameters. It can hurt performances on other examples potentially. So we have to do this sensitivity analysis, whether it's not impacting language model in a way that we don't want. But there are some good things. It can now integrate a larger amount of information, and the inference cost is fixed after we did the editing. This is the results on GPT-Neo. In the paper, we did a couple more language model, like GPT-2 XL, and the more recent one also have Llama results. They all have like relatively similar trends. And after we do this, continue to fine-tuning or pre-training, let the model to remember the definition, we can see the perplexity has dropped from 31 to 28.5, so that like there's like some gain, but it's a lot worse than when you were prepending the definition. So it seems like there are these two things. One is whether the model memorized certain facts, but then there is another challenge of being able to recover this knowledge at inference time and use it. And it seems to be the model is having a hard time of like recovering or like finding what's in the parametric knowledge. So we propose a new approach called context distillation. And the motivation here is that like, the prepending definition works great. So maybe like we can update such that the model will gonna imitate this prepending setting. So this is the probe sentence, and this is prepended definition. And we want the model to behave more like this prepended definition when just given the probe sentence, right? So we are going to have a teacher model and a student model. Teacher model will be given the definition. Student model, we're going to only see the probe sentence. And then you are going to update the student model so that the prediction logits for student model, we're going to mimic the logits of the teacher model. Pretty classic distillation setting, but we don't even have to use the bigger model here. It can be the same model, but just with different input. This has been used in other tasks such as prompt injection or alignments, but here we are using it for knowledge editing and injecting. So that's the idea, but we cannot use our evaluation sentence because it's come at inference time. So what we are going to do is we are given an entity definition. We're going to generate multiple sentences as just like a continuation of the sentence, let the model to generate a couple sentences relevant to it. And then given those continuations, you update the models to mimic the behavior of the prepended setting. Step 1, generate the transfer set. Step 2, do the distillation on the transfer set. And that's how we inject the new knowledge into the model. So after we do the injection, we evaluate our model on the same benchmark, see how well it can do. And you can see that we see substantial gains from this fine-tuning. Now it's dropped to 25.3 perplexity. It's still worse than 21.9, which is the prepend setting, but it's better than the fine-tuning setting. And we did something similar to the study that we did here of prepending random definition. Here, we are distilling a random definition into the model and see how that hurts the performances. And we can see that the model's performance hurts compared to just providing inputs, but the damage was not as bad as prepending the random definition. It's kind of interesting, like, you can inject the knowledge into the parameter space, but then it's the correct information is harder to find, but then also at the same time, the wrong information hurts the model less. I think there has been like more and more work on this knowledge updating. There has been like many papers, like reverse recurse, like A is B, model remembers A is B, but cannot recall B is A. Yeah, I think the parameter updating and how can we shape the model in a way that humans do so that they can be consistent about the knowledge and then be able to use the knowledge it has when it's doing inferences on other things are active areas for research. Question?
Yeah, I know, like we're talking about absolutes in here, but let's say, for example, we said, who is Kendrick Lamar, for example, and it says, okay, it's a singer in the US. But let's say in 2024, there will be a new Kendrick Lamar, which located in Germany. Both of them is true, but there is a different person. So what will be happen then? Both of them is.
And that's a great question. Actually, one of my students is working on interactive question answering. So there, I think the right behavior is asking a clarification. Do you mean the Kendrick Lamar in US or the new Kendrick Lamar who popped up in Berlin or something?
Okay, thanks.
Yeah. I think a lot of these things are like this kind of one-hot interaction is pretty limited. Great question. Yeah. So I discussed this knowledge augmentation through parameter updates. It seems that injection and propagation is both more limited than the retrieval-based augmentations. But then the context distillation that we tried seems to be working slightly better than the memorization fine-tuning approach. And there are like significant room for future work. Like one thing that I wasn't super happy with our previous paper was that we weren't able to ensure the sensitivity very carefully, like whether it really impacts the other sentences or not. So what we did in terms of evaluation is we look at other sentences and then see whether the perplexity on those changed or not. But I think I think that can be studied a little bit more carefully. And here we injected up to like facts about 150 entities at once, but I think doing it in a more larger scale is something that's needs future studies. And yeah, I think everyone these days, I don't know, my student is still working on these directions, and there are other people working on it. And I think many papers that I see in this domain, a lot of papers are about negative results, like language model cannot do this. But like, yeah, I think we all want to figure out how can you do this knowledge augmentation through parameter updates more reliably and better. Yeah. Oh yeah, I think the other thing that we're actively looking into is like doing the knowledge propagation across languages. So injected information in English, can you recover in Turkish or Korean or Spanish and stuff like that? Yeah. Okay, yeah, that's all I wanted to cover today about this like two different ways of doing the knowledge augmentation. I think both has pros and cons. Yeah, Osman.
My last question is that like compared to other models like Rome, like which kind of specifically like specify the like the weights that they want to manipulate, but you just fine-tune the whole model. So I was just curious about like what does this like approach change in the model so that it works better, you know? Like what kind of weights in the transformers does it change so that this is the best working model. Like, do you plan on working on that, or?
Yes,
Yeah.
actually, we did evaluate on their data sets, on their settings, and I think one thing that we found is actually our approach is slightly worse in the specificity. So their model really makes a like very local change, so it doesn't hurt other inferences as much. But I think we are making a bigger changes to the model, so we see some more degradation in some of the sensitivity of like, these are sentences that shouldn't change, but we see a little bit more changes with our model. So yeah, but I think it's really hard to decipher what's going on in this dark big model. So yeah, I think another thing that we consider is like maybe do something like adapters, where instead of like updating all the parameters, have like small amount of parameters that we can update. Yeah.
Okay, thank you.
Omar?
My question is related to benchmarking this language based on facts. I mean, there was a recent research that shows like GPT-4 knows who is the mother of Tom Cruise, but doesn't know that the mother of Tom Cruise has a son as named Tom Cruise, which means that the models are not capable to associate this semantic equivariance. Given that you expect at least we say that model is good at giving the correct answer. At least it has this fact, but in fact it can't really associate this fact, which means it doesn't really have this fact. I mean, what do you think on like benchmarking on this fact? Because they can be really in different forms, which may favor some models or may disfavor others.
Yeah, I think those are interesting questions. Yeah, I think benchmarking, those are interesting. I think one thing that I wanted to say about that A is B and B is A is like, in a sense, it's not that surprising. Because if you think about entities, some entities are way more prominent than the others. So say in relationship between A and B, like if you see A, then it's so one example that I say is like about like Charles Darwin, and there was this house that Charles Darwin passed away. And whenever you look up this house, then always Charles Darwin shows up, because that's like most important thing that happened to this house. But then when you search Charles Darwin, this house almost never comes up, because it's not a very important facet of who he is. So the fact that you can like recall one based on this entity trigger doesn't mean that it should work the other way. Yeah, I'm not sure I'm answering your question, but yeah, I think these are interesting questions that need further studies.
But the main question is whether model should be able to associate this semantic equivariant property if we think that they generalize or they are able to answer simple questions.
I think
That's why like just asking a question in a one way model maybe tend to answer always in this way, which may not work in practice, or which may work worse in other set of data sets.
yeah, I don't know. I'm not a philosopher, and these days I feel like we are making more like whether language models should do this or should not do this. I think it's gonna be easier to use if it's like more consistent across depending on however we are querying. But that's not the model that we have at the moment. I think it would be nice, but I'm not sure I would go as far as it should be. Yeah. Question?
Me, right?
Yeah.
So like I think that for example, we have a positional encoding inside of the transform, right? What if we just use something like date encoding? So maybe
there has been a study that's doing this like temporal indexing. It's from Google called temporally something. It's Jacob Eisenstein and Juan Dingra. That does help to index like which timestamp this document is from, but that doesn't completely solve the problem. Yeah.
Okay, thanks.
Yeah, it's a good idea though.
I think like the time is up. Like it's 6:30 right now. So like thank you so much, Professor Choi, to attending our talk. It's really nice to hear these really beautiful information from you. So yeah, I think this is the end of our talk. So like, see you everyone like next week in our next KUIS AI Talks.
Thank you very much. Thank you
Thanks
for
for all the
explaining
great
very
questions. Yeah.
Yeah.